One of the most important considerations in chemistry is the amount of heat that's involved in chemical reactions, and this is expressed using a thermochemical equation. It gives us a balanced chemical equation, and it also gives an amount of heat energy that's associated with the balanced chemical equation as written. For example, in this case, we see that every mole of N2O4, when it reacts, is going to absorb 57.9 kilojoules and produce 2 moles of NO2. So when we look at this problem, we want to find out how much heat is absorbed when 7.6 moles of NO2 is formed. Or in other words, if we produce 2 moles of NO, 2 moles of NO2, that's the same as consuming 57.9 kilojoules of heat. We're going to use our values of delta H in the same way as we've been using mole ratios. So here's how we would set up this problem. We start with our measured number, 7.6 moles of NO2, and we want to compare that to heat. And we're going to use this balanced chemical equation to tell us that producing 2 moles of NO2 is the same as consuming this amount of heat. And if we look at our units, we see that they cancel out moles of NO2, and we're left with units of kilojoules of heat. Now we're not quite done yet because we want our answer in joules. So we use the fact that a kilojoule is equivalent to 1,000 joules, and now we have our amount of heat in joules.